Hi, everyone. Welcome to my talk about the missing chapter in the platform engineering playbook. My name is Rotem. For the past 4 years, I've been the CTO and co-founder of a company called SREday. As part of my job, I have the pleasure to be the maintainer of two fairly large open source projects. One of them is called Ant. Ant, started by my co-founder Ariel when he was at Facebook, is an entity framework for Go. Today, it's part of the Linux Foundation. And Atlas, which we will be discussing today in part, is a database schema management tool. And the main argument I'm going to try to make is that platform engineering has been ignoring database schema management, and that's an issue. And to make it a bit more entertaining, I wrote you a children's book. It's not me, it's an AI agent who writes stories today. So it goes a little bit something like this. So the prompt that nuked the database. I hope you enjoy it. Oh joy, thought Alice. This task my interest piques. My lovely product manager wants all emails be unique. Busy as she was working on the next release, she asked her trusty copilot, write this tricky part, please. A sprinkle of AI magic. Alice grinned without a care. It dazzled through the data model. Unique, true, appeared from thin air. A thought then struck Alice. Her eyes lit up so bright. To sync our code and schema, a migration we shall write. So prompt away she did. Write me a migration, my good old friend. It cheerfully obeyed the bid, not knowing how this all would end. She ran it all so neatly. Locally, it worked just right. In dev, the checks passed sweetly. Looks good to me. Approved on site. Confident, she merged to master. Watched the green checks all align. The build rolled out a little faster. It all looked smooth. It all looked fine. Oh, can you hear that quiet? A calm so soft, so warm. But something steers beneath it. The silence before the storm. And then CPU alarms were blaring. The DB strained and cried. Unrelated queries hanging. Connections multiplying. The user's table choking. The errors rolled along. The team was left there thinking, but what had gone wrong? Or what had gone wrong? Okay, so I hope you enjoyed that. This talk is a postmortem about this incident. We're going to try to get to the root cause of why it happened and what we can learn from it. So on the surface, what happened, we had a developer, they had a very simple task. We have a user data model. It has an email field. We want it to be unique, pretty typical requirement. So we're using GitHub Copilot. We're asking our code assistant to make the change for us. Simple enough. We're using SQLize.js and ORM for Node.js, very popular. And the Copilot adds the unique attribute. Now, we know that any changes to the data model need to be reflected in the database. SQLize.js, the ORM comes with a migration tool. We ask it to plan the database migration. Basically, we need to apply the unique constraint to the user's table. And this is real screenshots. The code is actually correct, did a pretty good job here, but still something happened, right? We tested this locally, it worked fine, tested in staging, went fine, went through code review, went through CI testing, whatever. But when we go live to production, our system blows up. And externally, what we see is that the database CPU goes through the roof. We start to see a very high error rate on many critical endpoints. And of course, most importantly, our management is not satisfied with this situation. So anybody know here what happened? Why this happened? Okay, so during the incident, during the outage, so our engineer, she looks at our database is PostgreSQL, quite common nowadays. And she looks at the log queue. There's a system table she queries, and she sees that there is a queue of logs piling up. And what happens is when you ask the database, when you ask PostgreSQL to make a non-unique column unique, in order to maintain all of the database's guarantees, What it needs to do is to take an access exclusive lock on the table. This is the most restrictive locks. It basically stops the world for the table, no reads, no writes to the table while the operation is happening. Now, if the user's table is large, what the database does next, it does it anyway, is to do a full table scan and to look for duplicate values, because we cannot add a unique constraint to a database that has duplicate values. So if this is a small table, the lock still happens, but it might happen in an instant. But for a large table in a busy database, as our users table is, in this case, this can take minutes, can take hours, even longer. So during this time, any request involving the user table is going to start hanging. We're going to have connections pile up. Ultimately, our system is going to crash. So that's our explanation. I hope you learned a little bit of PostgreSQL if you didn't know about this. But why did it really happen? As SREs, as DevOps engineers, many of us are versed in the practice of the 5 whys. We want to get to the root cause of something, so we ask why 5 times. So why did this incident happen? The API stopped responding because the migration locked the table. Why did a migration lock the table? Because our dev shipped broken code. But why did they do that? This broken code wasn't caught in our CI system or in our staging environment. But why did that happen? Because as a team, we rely on human review to detect issues with schema migrations. But why do we do that? And I've been in this business of infrastructure and building stuff for developers around databases for a while. And since we started the company, interviewed dozens of people in this space. And a common theme when we ask platform and DevOps people why they don't have any automated infrastructure for this, the response is usually, I don't know. Migrations are an application dev problem. The app dev teams are responsible for the schema, so they should manage it. This is something very common that we hear. But migrations are a very risky business. When we're changing the database, arguably the most critical part in our application, there are risks. If we are not careful, we can accidentally drop the resource that we did not intend to. We might accidentally drop tables in the environment we didn't intend to, but destructive changes happen. And you might think this is something that, only happens to clowns, but if we look at incident from last year from Resend, a very popular email provider, 456, database migration started. 457, notice tables were being dropped, so they did not have a good time in that morning. Something that can happen to anyone if we're not careful. As we have shown before, when we are changing constraints in the database, we have all different kinds of failures. The lock we touched on, but migration can fail because if we have a duplicate value and we're trying to make it unique, the migration might fail. If we're using a database like MySQL that has implicit commit, meaning there's no transactions for DDL statements, then we can be stuck in a state between this version 1 and version 2. We're now in limbo. We don't really have a way to roll back without doing manual intervention. So not a lot of fun to deal with constraint violations being broken in migrations. Breaking changes, just like your mobile app or your web front end has a contract with the backend, your backend has a contract with that database. When you rename a column, you make type changes, stuff like that, you can break the contract by accident, causing queries to fail because your backend is going to issue queries to the database. The database is not going to know what the backend wants, and stuff is going to start to fail. And finally, in different situations, we mentioned one, but for example, in MySQL, if you have a column with an enum value and you try to change that to enum's options in a certain way, it's going to cause the database to need to rewrite the table from scratch on disk, which takes a long time, and it acquires a lock on the table. So there are certain kind of changes that if you do them in the wrong way, can cause pretty bad impact to your production environment. And the bad news is that it's going to get a lot worse. And spend a lot of time in the past 6 months to think about what Gen AI, with our children's book, what does it mean for database schemas? And I think, based on my conversations with people on our technical advisory board and colleagues, that a few trends are emerging now with databases and Gen AI. So one is a lot more code is going to be written with much lower focus. ChatGPT, GitHub Copilot, AI-infused IDEs can make you very productive. You're going to produce a lot of lines of code, but you're going to be a lot less attentive. When that means that you're going to make changes to your database, you can accidentally nuke your production environment without noticing. Things are going to go through code review because the one thing that LLMs are good at is to write text that looks real. So there's just an inherent risk in having a lot more code written with a lower level of focus. The second thing is that the average skill to write applications is going down. If you're seeing these new vibe coding platforms, this is going to come into the enterprise. People are going to build applications, build internal apps, build customer-facing apps. And for many of these new class of developers, they're going to write software. They do not know anything about the database, let alone about migrations. In fact, they prefer not to know that there even is a database. This means that despite these apps are going to need a persistence layer, and it's probably going to be a database, we're going to have a lot of software engineers that are not going to have any training. Not talking about the backend developer today that is not super expert in PostgreSQL. I'm talking about a new class of engineer that actually does not know anything about the underlying infrastructure. Moving from development to the production environment, we're already seeing this happen. People are writing agents, so these autonomous systems that are running inside the enterprise and trying to gather information from all sorts of sources. They're pulling stuff from the CRM, they're pulling stuff from the inventory, they're talking directly to microservices, okay? And they are creating a new kind of pressure on existing databases and new existing applications. If you think about it, we design our system with the assumption, many services that are going to be consumed by a human user, which can only do a few certain operations per second or per minute. But what if we're dealing with an agent that can do work at the velocity of a computer? This means that our applications are going to need to deal with new query and access patterns, and we're going to need to adopt to that. The most interesting implication to this point is, and this is something I heard from a colleague recently, is that even legacy applications that were developed 20 years ago, nobody touched the code base for over a decade, are going to suffer from this and also need to respond. Okay, so what is going to happen with the introduction of Gen AI into the enterprise is that we're definitely going to need platform guardrails. We want to support this agentic workflows. We want to support more people being able to write code, but can we risk the reliability of our system? We need to find a way to have all of this happen through guardrails. And in the short time I have, I want to present a short case study of one of our customers and how they built database schema management into their platform engineering organization. So really briefly, Unico is leading digital identity technology provider in Brazil. They work with the largest retailers, they work with the largest banks, and they have an amazing platform engineering team that supports a few hundred engineers deploying to a few hundred databases in production. The mandate for this team is to reduce complexity, to improve reliability of the systems of the company. And the challenge that they were dealing with was the database CI/CD gap, in their own words. So they had built extensive infrastructure for doing CI/CD for applications with GitHub Actions and with Bazel. They built a very neat solution with Terraform and Atlantis to make infrastructure changes. But right there in the middle of the stack, they did not have any automation solution for doing database schema changes. Results of this situation were, one is a very error-prone deployment system that's built on manual intervention, semi-manual execution of scripts, frequent outages, in short, a reliability problem for the company's service. They had some tools, but these tools relied on database expertise, so engineers still needed to understand Postgres and to author the migrations, or if they're working in SQL Server, to know about the different risks associated with different kinds of changes, which introduced a high cognitive load on developers and making them run slower. Sometimes they want to completely avoid certain kinds of changes just so they don't need to change anything about the database. And finally, Unico was working to achieve compliance with SOC 2 and a few other compliance frameworks. If you ever went through an audit, you know that change management is a very important part. You need to show that every change to production is documented, is approved, there's nothing manual that's going on. What do you do when you have a manual process and you still want to achieve compliance? A lot of documentation, Jira tickets, reports, all sorts of stuff that's really not fun. And they wanted to make this automated to make it easier for the team to stay compliant. So finally, the challenge was more difficult because, like many companies, when they reach this size of a few hundred developers, the tech stack becomes diverse. So they had teams writing code in 3 or 4 different languages, deploying to different kinds of databases, and they did not want to solve each permutation separately. So they wanted one tool to rule them all, one thing to be a platform capability such that doesn't matter which programming language we're using, doesn't matter which database we're deploying to, we have one tool for them. So I think now is a good time to introduce Atlas. This is the thing that we've been working on for the past 4 years. Atlas, sometimes been called Terraform for databases. It does a few other things that are relevant for this case study. We open sourced it in 2021. It's used in thousands of companies in production. And with Atlas, everything starts with code. Okay, so we want to cut the mental overhead for the developers. We understand the schema from their code. So in this case, if we want to make a change to the database, we're editing the ORM model directly. Once we change the desired state of the database, we can run Atlas migrate diff. This is a command that calculates the migration automatically for the developer. What it's going to do, if there is a change in the schema, is going to plan the change for the developer. The developer does not need to know the exact SQL. Okay, if we run it again, we get a no op because the schema is already synced with the migrations. I said database schema as code. In this case, I showed some specific ORM written in JavaScript, but the flexibility of our tool is that it has a way to import schemas from different sources. So you can use plain SQL if you want to define schemas as create table statements. We have a flavor of HCL very similar to Terraform, and we support all popular ORMs. You can even use a live database as the desired state of your schema. After I plan the change, I want to get some feedback. I want some expert to take a look at it. So I have another command called Atlas migrate lint. This runs the new changes through a form of static code analysis. It's not AI, it's real formal validation. So we take a look at the migrations, simulate them, and understand the impact. So we're telling the user the migration might fail in case there are duplicate values. And of course, warning about the access exclusive log. Okay? As a developer, very convenient to get feedback on the command line or in your editor. But of course, where this becomes more popular is if you integrate it as a CI step, as a guardrail, where the team, the platform team or the tech lead of the team can define the policies. And for example, in this case, we plan the destructive change, okay? And we have made it such that the build will fail. So the developer cannot merge a change that's going to delete data from the database without getting an extra step of approval. Once we went through CI, we're happy with the migrations. We need to deploy them somehow. So we try to be very versatile and let our customers choose the CD, the machinery that they want. We have a Kubernetes operator, Terraform provider, GitHub Actions, and all other CI runner integrations. So using these tools, Unico built for their developers an end-to-end solution where they do not need to think about database migrations. They only modify their application code. The platform generates migrations for them. They have a CI step to make sure that nothing slips through the cracks. There are no surprises in production. And the deployment of changes is no longer a manual step that happens by someone a moment before you're deploying the application, but it's actually just part of the same Kubernetes infrastructure with a proper Kubernetes operator. Things are rolled back in the same way that the application is rolled back. So it's a very smooth thing. It's not this thing I need to think about all the time as a software engineer. The results, with automatic migration planning, developers no longer need database expertise. This releases a bottleneck for many teams that have one dev that actually knows something about Postgres. They no longer need to review every pull request, only define the policy by which pull requests are going to be automatically evaluated. Automatic code review, of course, stuff runs much faster and reliability is higher. We don't have any more database surprises in production. Automated deployment, we don't have the human error factor anymore of running the migration on the wrong database or running things in the wrong order, copy pasting with a missing semicolon, something like that. And from compliance perspective, everything is audited. Much easier when everything goes through Git. Every change is tracked in a centralized system of record. So the result, month over month, as teams are adopting Atlas inside the organization, smaller and smaller incidents. So trying to answer questions from before. Should platforms take upon themselves schema management? We founded a company to solve this, so obviously we think so, but I'm trying to explain why on a more principled level. So like with DevOps, I don't know, I've read, preparing for this talk, 10 different definitions for platform engineering, what it is, what it does. Try to boil them down for me. It's not academic definitions, just things that I think about when I'm talking to platform engineers. What do they care about? Number one, reducing cognitive load. Super difficult to be a developer, much more difficult today. Much more difficult than when I started writing apps. My stack was much smaller. Everything fit in one VPS. The database was much, much simpler. Today, devs need to know a lot more about a lot more things. And anything we can do as platform engineers to make stuff simpler for them, to do vertical integrations so they can focus back on application code, is better. So that's something we're trying to achieve by abstracting the database, planning things for them. The second thing is to increase reliability. We all hopefully sell products to customers. Customers rely on us. We don't want to provide bad service. So anything we can do to reduce the chance of an outage as a platform to help our developers run faster is going to have a positive impact. And finally, talked about running faster. One of the interesting things we see about teams that adopt Atlas is that they move from barely changing the database ever to making them on the fly, like 10 different changes to the database in a week, because it's not an issue anymore. It's not scary anymore. It doesn't require me a lot of research, just something like change my Java code and things happen for me. So, key takeaways, the missing chapter. Schema migrations are a risky business. There's many ways that I'm seeing the smiles on some of you. We've learned this in our careers. It's something that if we could avoid doing, we would. And the bad news, Gen AI is starting to make things much, much worse because we're going to have a lot more software, a lot more bugs, a lot more people writing software that are not trained software engineers. We're going to have autonomous systems creating new pressure on existing systems. We're going to need to adopt much faster. Adopting faster is good, but it's only good if you have the guardrails to do that. So I hope in this talk I convince you that we shouldn't think about schema management as an app concern, but actually to bring it in to our platforms as a common capability. Thank you for your time.